Hello, today I will demonstrate a confidence interval dealing with population proportions. Now, our made-up example here is in a random sample of 458 Victoria County adults, 124 said they prefer to complete their grocery shopping in the morning before 11 o'clock. Now, I'm going to ask a couple questions, finding the sample proportion and find the standard error until we build up to the confidence interval that I want us to create. So find the sample proportion. This will be labeled as P prime. P prime is related as x out of n, so part out of a whole. Now there's 124 out of the total 458, so 458 is our sample size that came from the total random sample, and the 124 was the part of them that prefer to complete grocery shopping in the morning. Now, if I take my calculator and type 124 out of 458, it's not an ideal value, but we can approximate this to be about 27074. About 27% is close to that, right? If you multiply a proportion by 100, you can get percentage. So the sample is saying, well, about 27% of our sample like to complete grocery shopping in the morning. But we know that that's just for the sample. What about the whole population? We want to make an interval to kind of predict where the actual truth lies. I'm also keeping at least 5 decimal places so that I can reduce my rounding errors. So find the standard error. Standard error is actually sigma, and I'm going to put a P prime here to reference that I'm talking about the standard error for my sample specifically. So I'm going to relate specifically to the sample. The formula goes as so: P prime times Q prime, but we know that Q prime is really 1 minus P prime. And then divide by the sample size. So I'm going to put all of this in my calculator, and I'll put 0.27074 multiply by 1 minus 0.27074, divide all of that by 458. So we'll approximate this after. So we take the square root, 0.27074, parentheses, 1 minus 0.27074. I'll close the parentheses, hit division, and 458, and then hit enter, and I'll also take at least 5 decimal places again, 02076, and this is my standard error. Now, the reason we find standard error is because we need this when we find the margin of error. So continuing on, we're now to the part where we can start building the confidence interval. So we want to find the 99% confidence interval for the proportion of Victoria County adults that prefer to complete the grocery shopping in the morning before 11 o'clock. So in order to do this, like I said, we need the margin of error, which I'll label as ME, and this is equal to your z-score. We'll use the alpha over 2 for the 99% confidence level, and you multiply that by your sigma, your standard error that we calculated from before. So we need to figure out what the z-score is, but we know that the standard error from before was 02076. So I will place that just from what we found a little bit ago. That goes right here. Now let's talk about the z-score. The z-score, okay, which one of these are we dealing with? Well, we have 99% confidence. So our CL is 0.99. That gives me an alpha would be 1 minus 0.99 would be 1 minus 0.99 gives you 0.01, and then alpha over 2, divide that in half, you get 0.005. So I will be using this column. 2.576 will be my z-score. Now another way to find that is by using the inverse norm in your calculator. but I have created a different video to show you how to find that. Now let's multiply 2.576 times 0.02076. Enter. So our value is 0.05348 if we round to 5 decimal places. And now we need to build the confidence interval. To build the confidence interval, you take p prime and you add the margin of error, and you also have to take p prime and subtract the margin of error. This will create your lower bound and your upper bound of your interval. The lower bound would go with the subtraction piece, right? Because if you take p prime and subtract, you're going lower. And the upper bound comes from addition, right? If you take it and then add, you're going to get a higher value. So what we want to do is take p prime, and p prime from before was our 124 out of 458, just to remind ourselves, was 0.27074. And so we'll take 0.27074, and if I subtract 0.05348, hit enter, we'll get our lower bound of 0.21726, and then we can find our upper bound. We do the same thing. Now here's a trick: hit second enter and it'll retype what you did, and then use the arrow to go over to the subtraction and just change it to addition. Enter, and then we have 0.32422 for our upper bound. So here is our confidence interval. We are happy with that. Let's check this in the calculator to see if we get the same value. So in our calculator, I'm going to say check with technology. What we need to do is hit the stat button, go over to tests, and go down to the intervals. So we have a z interval, a t interval, 2 sample z interval, 2 sample t interval, and then 1 prop z and 2 prop z for intervals. We are going to be taking 1 prop z interval. The 1 stands for 1 sample was taken, which we have. The prop stands for proportion, and z, we always use z-scores with proportions. So I will hit enter here. Now it's asking for x. X will be my 124. That's the part that I was interested in, the part that did grocery shopping in the morning. N is our total sample size, so 458. C level, well, that's our confidence level, but we don't want the default 95%, we want 99%. So we'll change it to 0.99 and then hit calculate, and we should see 0.21726 and 0.32422, which does match exactly what we had. And then you see there, it gives you a p prime or a p hat. That's the sample proportion is 0.27074, which does match with exactly what we found in our very first step. So now that we know that our confidence interval has been created appropriately, we need to write a statement of conclusion. And our statement of conclusion will always relate back to the population. So it'll always say something about the population, and it'll say something about our confidence level we were interested in, and give the confidence interval at the end. So we are 99% confident, right? It mentioned the confidence level, that the true proportion of all Victoria County adults, right? It's talking about the population that prefer to complete their shopping in the morning before 11 o'clock is between 21.7% and 32.4%. Now, we can do this because these proportions really relate to our percentages, part out of a whole, a ratio. Now, with confidence statements, we also want to make sure we reference the situation that we were involved with, and that was the shopping in the morning, the grocery shopping. Now let's complete our example here with using the +4 method. With the +4 method, you pretend that you've added 4 to the total sample. What you do is you actually add 2 to success and you add 2 to failure. So what you do when you create p prime again is you add 2 to part of it, but 4 was added overall. So in our example, we had 124. We'll add 2 to it, and then we'll take our 458 and add 4 to it. So we really have 126 out of 462. So I'm going to do this in our calculator. We'll go to Stat, go to Tests, go down again to 1 prop z. What I will do is do exactly what I just did. I added 2 to the x values, and I added 4 overall to the total. And 2 of those went to x, and then 2 went to everything else. So then when I hit enter, right, you see it does 126 and 462. We'll keep the confidence level that we wanted, and we'll calculate, and then we have our new interval. Now we have an interval 0.21936 to 0.3261, which if we wanted to convert to percent, you could move the decimal place to the right twice, so 21.9% to 32.6% if you round. This would be our new confidence interval if we used the +4 method. Thank you for watching my video.